right, so vector components. Vectors which add to create a vector are called the blank of R. Components, did we already do this?
Don't say that.
Fun fact, I broke my pen. I pushed too hard on the tip and it broke.
But she sucks.
When working with vectors, it's most useful to resolve a vector into its rectangular components. Horizontal, which is your x, and vertical, which is y. The screencast is uploaded. Example 3. While digging in his garden, Oren. While digging in his garden, Oren pushes a shovel into the ground with a force of 630 newtons, an angle of 70 degrees with the ground. Whatever. Did you guys see your homework? Aha.
Yeah, I didn't understand.
Sarah, you're in the homework.
Use mine on the test.
Wait,
If it's not 8.1, it's 8.2.
I was at 8.1 and I was older.
No. All right. Draw a diagram that shows the resolution of force that will exert. Oops. That Oren exerts into its focus. Okay, so this is like what the homework was mostly about, because this is the important thing. This is what you have to know how to do. Cool. There's also, one of the reasons why I'm having the 3 homework assignments due on the test. That's when it's due. It's only 3 of them. They're a little longer, but each lesson's more or less like 2 days. So, all right, let's focus. Let's focus. I know you only have a couple days left, seniors, but let's get it.
You do.
I'm honored. Draw a diagram that shows the resolution. Do you hear that?
What?
The sound of you guys wasting my time. So, Yup. Time wasters. All right. Draw a diagram that shows the resolution of force or exerts into its rectangular components. Okay. Here's the shovel.
Shovel.
It's being put into the ground at an angle of 70 degrees. So we want to, and he's, pushing with 630 newtons. Sarah, who's talking? Haley's talking. What are you doing? I knew it was that corner. You 3 need to be separated. You 3 need to be separated.
No, I wasn't doing it.
Look at us. We're on the limelight anymore.
As she puts herself in the limelight. Okay. Draw a diagram that shows the resolution of force. So here is the y component of the force. Yeah, so for Jonah, who took physics with me, this is going to be like a solid chapter.
Yeah.
As long as you remember retention. All right. Do you remember doing this? You can say no. I won't be mad. Okay. Okay. Summer school physics. All right.
I do.
All right. So we just want to show. The horizontal vertical components. This is very much like the homework. And then B is find the magnitude of the horizontal and vertical components of the force. Okay, so throwback to the first week of class. How would we do this?
Throwback Tuesday.
Okay.
Oh, wow. Deja vu.
So sine of 70 degrees is going to be equal to the opposite, which is the force in the y direction, over the hypotenuse 630.
And when it says into its rectangular components,
That's x and y,
oh,
because that's Cartesian coordinates, rectangular coordinates. So we want it into x and y parts.
okay. So whenever you just say rectangular components, that just means
X and y. Yep. So up here you'll see rectangular components, comma, horizontal and vertical. All right. Find the magnitude of the horizontal vertical components of the force. So multiply by 630 on both sides. 630 times sine of 70 degrees is equal to our force in the y direction. So what will that equal? Get out your calculator. It's math class time.
FY?
Let's see. Yep, force in the y direction.
So there's an FY button on our calculator?
Not at all.
That's like-
Literally putting in 630 times sine of 70.
FY.
630 times sine of 70 degrees is equal to the force in the y. It's the y component.
So Fy is like X, right?
More or less. What is it, Jonah?
0.006.
Point
0.01.
101. Blessed. All right. Okay, so that's the vertical. Now we need the horizontal. Newtons, because that was the unit up here. It was said newtons up here. Okay. You have two calculators.
This is completely
Huh?
different.
What? One more time? Is this something that's constructive?
Yeah. Never.
This is like number 2. Yep, this is exactly like number 2 on the homework.
This is like all the problems.
Yep, more or less. Which is why I'm giving like 15 minutes in a class to hit some of those homework problems with you guys. Cool. Cool. All right, so vertical. So if I want to do cosine of 70 degrees, that's going to be the adjacent, which is the force in the x direction, over the hypotenuse, which is 630 newtons. Multiplied by 630 on both sides, I have the horizontal force is just 630 times cosine 70 degrees. So what would this be? I mean, you don't need it. It's just a number, but you have to make sure at the end, put the unit at the end. I just didn't have it. You can, yeah. It's just,
Can we only do this for sine and cosine, not tan?
Well, I was given the hypotenuse because that's the resultant vector. I want to split into x and y. So x is literally cosine, right? Hypotenuse times cosine x.
But how do you know?
Yes. What?
How do you know which way the arrow to draw the arrows?
Okay. So if you have a shovel, are you gonna go in the air or are you gonna go into the ground?
That was a stupid.
It's not a stupid question. It's a good question. It's all about context. My point is,
Could be
point is, you have to think about the problem. You have to think. You can't just like wrote like, here it is. Like no, like okay, which way do shovels go? Down. Okay. Which way is this pulling? Okay, it's pulling this way. Like you have to think about it. It's not just like.
Down to the other
So I'm gonna try to give you like some real problems. Try to give you like real things, not just random stuff in the book. All right. What was this equal to? 0.47. All right, and then make sure you put n because that's units. That's the Newton. All right. We're gonna go ahead and do 8.2 vectors in a coordinate plane. So this is more or less like the same thing. Okay. Real quick, look in your. Did everyone get a copy of the homework? I want to make sure I don't forget to do this.
No, I only have 8.1.
That is what I was Or I must have given it to you.
Yeah, I got it.
Okay, because I don't have an extra. Okay. Just want to make sure. Okay. Okay, that's fine. All right, so 8.2 vectors in a coordinate plane. What is that? I don't. Never mind. I don't want to know. Okay. So if I have. Any question? Okay. Cool. All right. So component form of a vector. The component form of a vector with initial point A, final point B is given by this. Notice it's literally your change of x, comma, change of y. Change of x, comma, change in y, and then it has these like special. It looks like less than, equal, less than, or greater than symbols. It's like the triangle brackets because it's vectors. Yeah. It was. Yeah. Cool. All right, so let's just do the example. I mean, I could show you here, but it's better just do the example. Should I do the example? No, let's do the example. Find the component form of AB with initial point 1, -3 and terminal point 1, 3. So I could just do this mathematically, like, cool, let's just, solve. But let's draw the picture and go through it. 1, -3, so that's, let's see, 1, 2, 3, so that's right here. So this is point A, right, because it's 1, -3. And then I have another point at 1, 3. 3. So here's B. And so what I'm trying to find is the component form. So this is this vector. Let's see. All right, so this vector is going from A to B. There.
Oh my god, that's
Oops.
so funny.
Heck yeah.
Thick. I love that.
That's way too thick. Oh god. Okay.
Thick.
That's like 4. Let's tone it down to like 2. All right.
No, it's cute.
It's like
She, thick. Thick.
Yes.
that's better.
No,
Aww.
no.
So cute.
It was nice.
Okay. Awesome.
Put her back. Wait.
Okay.
So funny.
So I have this arrow. I want to find the component form.
You draw an arrow.
What? Yeah. Yeah. All right. So find the component form of AB with initial point. This is going to be my x1, y1. This is my x2, y2. Okay, so the equation says x2 minus x1, comma, y2 minus y1, all right, bracket. So I'll go ahead, I'll plug it in. You'll see we didn't even need the picture, but it helps us context. Because right away, like before we even do anything mathy, what will the component of the x be? What is the y? Y is 0. 1 minus 1, okay, but without math, looking at the photo picture, it just goes, right, it just goes straight up. There's nothing like horizontal about it. Okay, so x2, so I have 1 minus 1, comma, 3 minus negative 3. This pen. Did you not see what was happening?
No.
It was like,
She said she broke it.
oh, you like that? No, I don't. It sucks. It like keeps like cutting out. It's the stupidest thing. Okay,
No, I misheard you. I'm sorry.
it's fine. I'm not mad.
You like it.
So
Nice pen.
vector AB is going to be 0, comma, 6. That's it. That's the whole problem. Okay, cool. Since magnitude of the vector is represented by its length, it can be used to find, can be found using the distance formula. So the magnitude of a vector can be solved using the distance formula. Do you remember the distance formula?
Y2 minus y1.
Ian knows it.
No, something
He's a smarty
squared.
pants.
Like it's Pythagorean theorem. A squared plus b squared equals c squared. Or you could say, like, surprise, I'm going down the page. Okay. Okay. So I have, this is my x length, this is my y length. So my x length squared plus my y length squared, square root of all of that will be my hypotenuse. I could show you, if you really want to see, it's like, you know, oops. X squared plus y squared is going to be your resultant vector squared, right? Because this is your x, this is your y, your resultant vector is the hypotenuse. So if I wanted to find the resultant vector, it's literally going to be the square root of x squared plus y squared. Where here, x is x2 minus x1, y is y2 minus y1. So the whole thing is going to be a lovely little, so this bar right here, this absolute magnitude, that just tells us that we're finding the magnitude. Surprise, absolute magnitude gives magnitude, gives just the number. Yep, exactly. Because if we're wanting the magnitude of the vector, I just want the number of the vector, I just want the length. So we can go through example 2. Find the magnitude of AB with initial point 1, negative 3 and 1, 3. You don't have to show a picture this time. So the absolute value, I don't know what to do. I think it, because I threw it in my
Can you use
bag.
your finger or no?
No.
Why? It needs like the specific sensitive.
Does it have ink on it?
No.
It's fine. Use a board marker. It's the old-fashioned. Oh, sorry, it's for the screencast. Sorry, everyone.
She said she left it in her bag. So.
I probably broke it that way. Alright, the absolute value, aka the magnitude of the vector AB, is going to equal the square root of x2 minus x1. So notice these are still the same numbers as last time. So x2, 1 minus 1 squared, plus y2 minus y1, 3 minus a negative 3 squared, and the square root of all of that. What's wrong? What's wrong?
Well, like banging on the wall.
It's fine. Ignore it. Okay. So that's going to equal square root of 0 squared plus 6 squared. So that's just square root of 36. So the length of this is going to be 6. So let's see, I know the vector AB is equal to 0, 6.
How do you get the zeros?
Actually, that's not what I wanted. No, wait, okay, that is.
I don't really understand.
So the component form of a vector, I'm at 0, 0x, 6y. So I'm 6 units long in the y. But if I want the magnitude, if I want the length of my vector, it shouldn't be a surprise that the length is 6. Yep. Boxed it. Because that makes sense, right? If I'm trying to draw a triangle and I have 0, x length, that makes sense that, okay, then my length is just going to be the y length. I don't understand what you're asking me. If it's asking for component form, you do this. It's asking for magnitude. And component form tells you the x and y components. Alright, Osher, wake up. So let's go ahead, let's do addition, subtraction, and scalar multiplication of vectors. It basically it looks just like matrices. That's why we do this matrices right before this. So if I add two vectors, you're going to add the x's together, you add the y's together. If I'm doing vector subtraction, you subtract, you subtract the x's, you subtract the y's, it's just like a matrice. For instance, if I had a matrice like this, you hate what?
I'm so confused.
By?
Because now I'm going to think this is a matrix.
I'm showing an example of how this is basically like matrices. So if I can make the matrice 1 minus 5, 2 minus 6, 3 minus 7. Do you see how they all line up with each other? Okay. If I go through and do this with vectors instead, it's going to be super similar. So if I do, let's see, 1, 3. If I add these together, yeah, so I'm going to have 1 plus 4, 3 plus 5. You add the first together, you add the second together. That's how it's like matrices, is the way it corresponds. You add, subtract together. If you multiply by a scalar, you just distribute to each of the components. Alright, so we can go ahead and let's do an example. Yep. Find each of the following for W, Y, and Z. Okay, so if I have 2 times W plus Y, 2 times W plus Y. Surprise, surprise, they're not in our room. Okay.
No, I asked you my turn. I can't.
Do you need to leave the room?
But I still don't know
You could go talk to your dean about your scaredness. Do you need to step outside? Okay, then pull it together. Alright, so 2 times w plus y. So what I'm going to rewrite this by using the vectors. So I have 2, oh my gosh, times the w vector. The w vector is 2 comma negative 5. And then I'm going to be adding the y vector, which is 2 comma 0. You writing this down? Okay. Yep, just a friendly reminder. Pencil should be in your hand. You should be writing. Cool. Alright, so let's deal with this let's deal with the scalar first. So I'll distribute the 2. So I have 4 comma negative 10 plus 2 comma 0. Because remember, these are both vectors. It's the x and the y component. So what we're going to do is we're going to add like corresponding parts together. So I have 4 plus 2. And then negative 10 plus 0. So our vector at the end is going to be 6 comma negative 10. Cool. And then that's it. We found the resultant vector. So for instance, we kind of did this yesterday when, like, if I would have given you the vector w and the vector y, what they were, you could have drawn them, figured out, like, this is my x component, this is my y component. This is more useful, so this way. Now let's do the next example. Am I good to move on?
Wait, I don't get why you're adding
Exactly. That's why I couldn't believe it when my other class came up and was like, people in C told me it was so hard. Okay.
It's going to get hard.
Alright, so do we understand how I did this? Let's go on to the next one.
No.
What's your question about it? What part do you understand? Because I'm supposed to be doing 2 times w plus y. So I doubled my w vector, and now I have to add them together. So I add my x parts together and I add my y parts together. Because remember,
X1 plus X2,
yep.
then Y1 plus Y2.
Let's go on to the next one.
Formula to like add them.
Let's go on to the next one. So I have 3 times y. So 3 times my y vector, 2 comma 0, minus, well, I could write this as plus negative 2 times my z vector, negative 1 comma negative 4. Yeah, I'm going to distribute the negative with it. Makes it a little easier. So let's distribute out. Let's see what we get so far. 6 comma 0 plus 2 comma 8. Yes, exactly. This is it. 6 plus 2 comma 0 plus 8. So I have 8 comma 8. That's it. See, you guys can do this. You can do this. Yep.
Wouldn't it be 6 minus 8?
No.
Oh, it changes to plus?
Yep.
When?
Negative 2
Negative,
times
negative.
negative 1.
Oh. Oh.
Hannah, are you okay?
No.
You okay?
Yeah. I just have like, I don't know.
Okay. Okay, cool. Alright. Cool. Alright. Clowns. Clown class. A unit vector is a vector that has magnitude 1. Remember when we talked about the unit circle?
Oh.
The unit circle had a radius of 1. The unit vector has a length of 1. Well, makes it pretty nice when we work with trig functions, because we already know the unit circle. A unit vector is a vector with magnitude 1. Consider vector v. Its unit vector u will have the same direction, both a magnitude of 1. So instead of being 2.5 units long, it's only 1 long. What is going on here?
He was on and I was still kind of.
Oh, okay. That's fine. I guess. Alright, so find a unit vector with the same direction as 4, comma, negative 2. Okay, so how could I even do this? How do I go from having a length of 2.5 to 1? What do I have to do?
Divide by 2.
Exactly, I divided by the length. Surprise. So, guess what? Oh my god, I don't have the length. I have the x and y coordinates. I have the x and y components. So if I find the resultant length, I could find the unit vector with the same.
Wait, which side is the x and which side is the y?
It goes x, y.
I don't know that when you draw that.
Okay, okay. So this is 4, and then negative 2 goes down, so that's negative 2. Okay. Your question? Okay.
Somebody can take that picture.
No. It was just showing you what a unit vector was with the length of 1. Right? Yeah, it's 4. 4 is positive. The 4 was positive, so I went positive direction for x. The y was negative, so I went down, step up. If the x was negative, I'd point it in the opposite direction. And then, if it was like a positive 2, I'd put it like here. Like, yeah. That's exactly what it is. No, it's not. I just.
No, I don't.
That's cool. So no, I'm not drawing it exactly to scale, but I labeled the numbers.
Okay.
And then I can find the length, the resultant mathematically. Cool. Alright, so the first thing I'm going to do is find the magnitude, the length of our vector v, the resultant. If it helps. Alright, so first thing we're going to do is we're going to find the magnitude, the length of our vector v. Right. How do I find the length of this? Someone already said it. Pythagorean, yeah, Pythagorean, more or less. So the absolute value of our vector, more or less the magnitude, the length, it's going to be the square root of a squared plus b squared. Find magnitude, magnitude. Yep. So here I know my lengths already. So I have 4 squared plus so 4 squared plus negative 2 squared, square root of all of that. So it's a square root of 16 plus 4. Square root 20, how do I simplify? Square root 20. Right, so 2 root 5. So I'm going to divide my vector by 2 root 5. I'll go through and divide it by 2 root 5. So that's step 2. So I'm dividing the vector by the magnitude, aka divide by 2 root 5. So I'm taking 4, comma, negative 2, dividing by 2 root 5. Dividing is the same thing as multiplying by
reciprocal.
Exactly. So I'm going to multiply it by the reciprocal. Yeah.
You can't have a thing in the denominator, you don't care.
I don't care if it is or not. I mean, I'm going to rationalize it, but you don't. So I have to. That I just erased. Yeah, it's a comma.
Why are you doing the commas?
What? It's because my pen is crapping out.
It wants to make an arrow so badly.
Is that better?
What if it's like a special vector?
No.
Vector commas.
No, it's just
Wait, is it better? Oh, wait, Optional because you can't have the square root of all.
It doesn't matter.
Oh, I missed it. It's sorry.
It's fine.
Then it's not okay.
Okay, so either one of these will work, that's fine. And this is the vector u, it's the unit vector. Because if I do Pythagorean theorem on this, I will get a length of 1 for the hypotenuse, the resultant. There. Okay. The unit vector in the same direction, the unit vectors in the same direction as positive x-axis and y-axis are denoted by I and j. I goes with x, j goes with y. What do you think the next one is that goes with z?
C.
Nope.
Oh,
I
K,
go.
K, K.
K, exactly.
K.
I hat, because it has a little hat. It's a unit vector. I hat. Yeah. Anyway, using these standard unit vectors, any vector can be represented as a linear combination of vectors I and j. So you have AI plus BJ. So we'll do example 5, and then we can we'll do example 5, and then we'll pause there. Yeah. We'll go over example 5, and then we'll pause there. Cool? Alright, so example 5, let DE be the vector with initial point D, negative 3, 3, and terminal point E, comma E, 2, comma 6. Write DE as a linear combination of the vectors I and j. Do we have any idea how to do this?
Well, I is the.
Yep. So first we need to find the component form. So find the component form. So I'll give you 10 seconds now. Find the component form. See if you can apply what we just learned. 15. Right. Component form, x2 minus x1, y2 minus y1. Yeah, so first we're going to do component form. Just trying to do a better job of taking attendance. So. Cool. Not that I don't do a good job. Normally I start with it, that's why. Okay. So let DE be a vector, blah, 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 blah. So first what we're going to do is find the component form, and then I can rewrite that in terms of I and j. Okay. So step 1, find component form. Of DE. Alright, so DE, vector DE is going to be, let's see, x2 minus x1, comma y2 minus y1. So that will be, let's see, 2 minus a negative 3, comma 6 minus a negative 3. So we will find that it is 5, comma 9, right? Yeah. Cool, okay, component form, check. Now what we're going to do is rewrite using a linear combination of standard unit vectors. Let's write down what I'm saying. Alright, so let's rewrite this using a linear combination of standard unit vectors. Okay, so the last example, we found the unit vector ourselves. You can use the standard unit vectors, I and j. I goes with x, I hat goes with x, j hat goes with y. They have hats because they're the standard vectors. Yeah, literally that's what it is. It's literally a hat. So, fun fact, in college, you know how like 18-year-olds are? Some of my friends, when we were taking calculus, they're like, lol hat. Oh, that's stupid. But they literally made like a lol hat. And why? Why are you the way you are?
Did you ever end up doing it?
No, it's
Too
stupid.
cool for school.
I am too cool for school, and that's why I'm still in school. Alright. Yeah. You know what I'm gonna do? I'm gonna start going on the circuit for stand-up comedy. I'll just tell stories about you guys. I'll make money, and then I'm like quit. Yeah, I'll talk about the time that I'll talk about the time where like I saw someone texting because I could like see under the desk. I'm like, what are you doing? Nothing. I'm like, please tell me more. Is your phone in your lap? No. I'm like, why are you like going like this? Do you see my thumbs? Like. But like I can like see. I'm like, what are you doing? I'm not texting. I'm like, okay, what are you doing then? Huh? What are you doing? I mean, my thumb itches. What? Just like own up. Like when I make a mistake, yeah, okay, I'm sorry, I didn't do it on time. What are you gonna do? Fire me? No. Like I get what I need to do. I get that done. Some of the other stuff I let slide. But I'll be honest with you, like I'm honest, and I'm like, nope, I didn't grade your test yet because people haven't taken it. I'm honest. All right, that's enough time to catch up. Let's write this. What? Yeah, that's my way of saying I'm gonna be a stand-up comedian, and I'm like, I'm done.
It's like cleansing, and you can make money.
Yeah, I'll make lots of money talking about being a teacher. Yeah. Yeah. All right.
This is awful.
It is. I'm gonna rack up my stories.
People like listen to other people make fun of it.
I told you guys how I accidentally broke a yardstick in like my first year teaching. So now I'm nice. Like earlier when Osha was sleeping, I was like, Osha, wake up, right? Like all calm and soothing. Now my first year, I was really hardcore. Like someone's sleeping, I'll grab a textbook, and I'll slam it right by their face. They don't sleep in my class. You know how like rude that is.
In 7th grade, there was this kid. His name was Cameron. And
Which one?
so they made this really intense history teacher named Rick. And whenever like people were taking.
Oh God. Okay, let's keep going. Let's finish this problem.
Wait, Ian just got caught off like a good story. It was a good story, but it's okay.
All right. So the hats denote that it's a unit vector. Shh. That was my bad. The hats denote that it's a unit vector. So I could rewrite this as 5i plus 9j. Yeah. I was just waiting for someone to say that. What are you doing? Yep. Okay, strut to your seat and sit down. Okay. Cool. So I can rewrite vector DE as literally 5i plus 9j. Okay, so we could like honestly finish the lesson today, but I want to spend 15 minutes going over problems from your first homework. Cool. All right, so that's half of 8.2. That's solid.